Question number 31. As angle theta is increased, the coefficient of kinetic friction between the bottom surface of the block and the surface of the incline will remain the same. The coefficient of the friction is basically the same for the same material, right? The only thing changed or affect the friction is the normal force, which is equivalent to the weight of the, not equivalent to the weight, but equivalent to the y component here of the gravitational force, but the coefficient is how rough is the surface. Okay, the rougher the surface, the more the coefficient. So that does not change unless it's a different type of material. And number 32. Three forces acting on the box on inclined plane, as shown. If the box is at rest, so net force is 0, well, it's 0, D. 33. In the diagram below, a 10 kilogram block is at rest on a plane incline at 15 degrees to the horizontal. As the angle of incline is increased to 30, the mass of the block will remain the same. The mass doesn't change. If the incline increase, then your x component of the gravitational force will increase. But the mass of the object does not change no matter what. 35 or 34. Well, projectile motion. Right? It's nothing more to talk about. Okay, the next question. Base your answers to the following question on the information diagram below. This is a projectile motion. The speed, initial speed VI, at a launch angle of 30 degrees. And then the time is 2 seconds. How does the maximum altitude of the projectile change as the launch angle is increased from 30 to 40? Assume the same speed. Remember, so when we learn the projectile motion, we know that 45-degree angle will give you the maximum range. So if it moves from 45, it will go higher and again go longer, right? So basically, the maximum altitude will be greater because the time will be longer, okay? 36. How does the total horizontal distance traveled by the projectile motion change? Same thing. It will go longer. So if the altitude is greater, right, then it will take longer to reach the top. And fall down. Because the time is the same for y and x. X is our horizontal distance, right? So since the time will be longer, distance equal velocity times time, times longer, so distance will be longer. All right, so don't worry about 37 because it is a free fall question. We already did that last semester. If you want to know how to do it, or if you want to recall how to do it, you can always go back to your notes before and then figure it out. Or you can ask me a question on the comment. Okay? 38. A rock is thrown straight up into the air at highest point of the rock path. The magnitude of the net force acting on the rock is 0. Okay? Imagine things going up reaches maximum, right? Remember that velocity at the maximum point is 0. If the velocity is 0, everything's just not moving. That means the net force is also 0. Okay? 39. A ball is thrown with an initial speed of 10 meters per second. At what angle above the horizontal should the ball be thrown to reach the greatest height? It's a common sense 45 degree. And 40, an unbalanced force of 20 Newton applied to 40 kilogram with net force 0. The acceleration is, oh my bad, the net force is not 0. It's just saying that unbalanced force applying to an object at rest. So A equal F over M, 20 divided by 40 is, oh, my bad, 20 divided by 4 is 5 meter per second square, which is B. And then 41, a student with a weight of 500 newtons sit on a chair. The chair exerts a force on the student of 500. The chair, the student, weight 500, then normal force 500.